Last night you used the example of Turner syndrome to give us an insight into how species can come into being. I'd like to ask you, if you have a woman, a fertile woman, rarely it happens, but you mentioned it does, who has Turner syndrome, and say that female had relations with her consanguineal brother, would the offspring of that union be a new species?
No. No. It will be a new species if the boy, at the very beginning, had a shift on his chromosome which corresponds to a new species. But that trick would allow the novelty of the chromosome to immediately be used in a new species instead of being selected against, because it will go in the hybrid state if it was to have as a conjoint, yes, if it has as a woman a person coming from a partner coming from the old species. Then, in order to build a new species, it's not enough to have the twins of different sexes coming from the same egg. This very egg had to be carrier of a chromosomal novelty. So you have to have the two things at one time.
So if that did happen, though,
yes,
then that would be...
Then there would be a new species.
And we only know, as you had suggested, maybe one time that happened.
Well, I'm not that sure that the trick of Adam and Eva is only for humanity. Maybe it has occurred on many species. We do not know that. But if we could produce it on mice, it would be the demonstration that it is possibly a general phenomenon, more general than we are inclined to think. So it's not a prodromal explanation. It's not an explanation ad hominem. No, it's maybe ad vitam.
Thank you.
Yes.
Dr. Lejeune, thank you very much. It was a wonderful presentation. You talked a little bit about different sensory modalities, the visual one in particular, and you mentioned how what we see is translated into some sort of electrical impulse or chemical impulse that will wind up in a certain part of our visual cortex. To some people, it seems like a leap of faith to suggest that because these certain electrical or chemical impulses arriving at certain parts of our brain actually allow us to understand these impulses or these visions that we see. Put another way, is the brain sufficient to account for our cognition or our consciousness of what we see?
Well, that is a very basic question that have no more understanding than anybody. We can understand how perception is becoming possible due to the disposition of the sense organs. Now, how we feel it, how it gets conscious, nobody has any explanation about that. But even if we consider the body and the brain as a machinery which is used by the soul, we have to see that this machine is already built according to the spirit. But it does not tell us more than that.
If I could pursue the matter a little further, you mentioned hydrocephalus.
Yes.
And there have been certain cases in the literature, I'm sure you're aware, of patients with hydrocephalus who in fact have normal or even higher intelligence than what we would normally expect of someone who has virtually no brain. Do you have any thoughts on that?
Well, that's the plasticity of the brain is much greater than we could expect. And you are perfectly right, we know some case. One is a professor of mathematics This man has got a partial hydrocephaly, which cured itself. But when you look at a, how you call it, a scan of his brain, he has only half a centimeter of brain left, and all the rest is just a big hole filled of water. And he is still professor of mathematics. That is the great surprise, that in fact, not the fact that being professor of mathematics is a proof of an extraordinary performance. It is in a sense, but not absolutely. But it means that the amount of nervous system which must be performing so that we can be conscious and efficient can be reduced enormously and still be usable. And that it makes a whole difference with a machine. If you burn a whole rack of electronics, the best computer is just junk. But our brain is not done that way. And we have the impression that we can re-educate some wirings so that they do something which they are not intended to do at the beginning by construction, but which can be used in case of necessity and change their, so to speak, their duties in the brain according to the necessities. We don't know how it works really, but what you say is correct. There are people who have lost more than 2/3 of the brain white, and still they perform quite normally. But you have others who have just a very tiny little lesion, and it gives them epilepsy, it gives them, and you have other cases in which only one chemical reaction does not go well, and it gives a terrible neurological devastating system. So that we have to be very careful about the relationship between the brain and the mental efficiency. There is an obvious relationship, but in each case we have to study it carefully before saying something.
Thank you.